Which NIAC project would be the best to bring to life? Are there really more stars than grains of sand on Earth? Is the solar eclipse going away from us? What's on my shelf behind me? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Biggles Tinted. If the moon is moving away from the Earth and the sun is getting smaller, will this offset the Earth not getting to see a total solar eclipse? Yeah, so the moon is slowly drifting away from the Earth. And right now, the moon and the sun are roughly the same size in the sky. And so we get to see total solar eclipses. Now, it really depends on the orbit because the moon's orbit around the Earth is elliptical. And the Earth's orbit around the sun is elliptical. And so you can have these times when the moon is at its farthest and the sun is at its closest, and the moon doesn't completely block the sun. You get this ring of fire. This is known as an annular solar eclipse. And so the moon passes like even dead through the middle of the sun, and yet the sun leaks out around all of the sides. But then you can have the opposite situation where the moon is at its closest and the sun is at its farthest, and you get the moon nicely blocking the sun, and you get a really nice long total solar eclipse. But because the moon is moving farther away from us year after year after year, there will come a time when we have the last total solar eclipse. And we can't know exactly when that day is going to happen, but it's roughly 600 million years from now. And there will be this time when we see that final solar eclipse. And then from that point forward, all solar eclipses will be the annular solar eclipses where the moon doesn't completely cover the sun. You get the ring of fire, and that'll be that. And it's like a fascinating coincidence that we happen to live at a time when the sun and the moon are roughly the same size in the sky, and we get to experience these total solar eclipses. And the civilization that is here on Earth a billion years from now, they won't see it. Some Rye. With the recent success of Starship and Bong, we will see more space observatories. I don't know how it will affect stargazing other than adding a lot of moving clutter. So Bong, I had to sort of call this one out because Bong, Blue Origin New Glenn. I've never called it that, but I think that's great. So I think that's the one, don't be surprised if I use that in the future. So yeah, absolutely. We're going to see more space observatories with these larger heavy lift rockets. And I don't think they're going to be very useful for removing clutter. The big problem is that all of the space debris that's already up there is already moving at 28,000 kilometers per hour, and each one is on its own special separate trajectory. And the only way that you can actually clean up a piece of space junk is you have to match the velocity. You got to fire a rocket, match the velocity of the target, get close to it, grab onto it with arms, hold on to it, and then somehow deorbit it again. You're looking at hundreds of millions of dollars for each piece of space debris. Like if you're going to remove a upper stage of a rocket that's 20 meters long, okay, maybe that makes sense. But if you're going to try to remove a bolt that's moving at 20,000 kilometers per hour and could catastrophically destroy a satellite if it hits it, are you willing to spend several $100 million to remove each bolt from space? Like it's already done. This problem is now locked in. And so there's nothing we can do about it. Even if super heavy lift rockets come out, we're not going to be able to clean up. But we should definitely stop making the problem worse. Like at the very least, have a plan to get rid of your upper stage of your rocket. Have a plan to get rid of your satellite when it reaches the end of its life. And right now, that is not required, but we're getting to that. The European Space Agency is working on a zero debris charter that people have to agree with if they want to try and launch rockets, where they have to deorbit their upper stage, any other parts of the system, fairings and so on, and then they have to be able to deorbit the satellite when it's reached the end of its life. Agent Dark Booty. Among all the NIAC interviews we've conducted, what technology do you most hope comes to fruition? That is an easy answer, and that is a mission out to the solar gravitational lens. Now, this isn't an interview that I did this year. This is one that I did a couple of years ago with Dr. Slava Turyshev, and he is the originator of this idea that if you go out to 550 astronomical units away from the sun, you can use the gravity of the sun as a natural telescope lens that then allows you to see an exoplanet and to be able to resolve features on the surface of an exoplanet with 1 megapixel resolution. In other words, you could have 1,000 by 1,000 pixels of an exoplanet. You would see oceans, mountains, forests, and even cities on that planet, even though it could be tens of light years away. And that's thanks to the magnifying power of the sun. And it is like, there is no other idea for a telescope that would get us a fraction of the resolving power of using the solar gravitational lens. And to accomplish it, to get a telescope, it doesn't have to be a big telescope, like a meter wide telescope, something that is half the size of the Hubble Space Telescope, out at the solar gravitational lens would give us this incredible resolving ability on an exoplanet. But also you could do anything. You could point, whatever you want behind the solar gravitational lens, you get this, I don't know how many times magnification thanks to the gravity of the sun. And that because it's so far away, 550 astronomical units, we have to come up with new propulsion techniques to be able to get out there. And that's Slava Turyshev's other ideas, like ways that you can actually accelerate to the point that you can reach the solar gravitational lens in a fraction of the time. And I've got a couple of NIAC interviews that I've done in the past about faster propulsion systems. I've got one in this round about a fusion drive that people are working on. So yeah, that's my choice. If I had to pick the one that I most want to see happen in my lifetime, it is for us to send a mission to the solar gravitational lens. Agent Dark Booty, would there be places in the universe where you could see dozens of galaxies in the night sky? Sure, absolutely. Here on Earth, we are part of the Milky Way. The Milky Way is part of the local group, and there are 3 large galaxies in the local group, which are Andromeda, M33, and Triangulum in the Milky Way. And then there are about 60 dwarf galaxies. And the 2 most famous are the Large and Small Magellanic Cloud. So right now, with the unaided eye, you can see 5 galaxies, but you can't see the other 55 in the local group. But you can imagine that there are places in the universe where you happen to be living in a much larger cluster of galaxies, and those galaxies are relatively close to each other, and you're going to be able to see dozens of them around you. It's got to be a place somewhere where this is happening. So, it doesn't work for us, but for other places, yeah, totally. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Keith Favreau, JP Masser, Colin Cooler, Nathan, Scott Holiday, Owen. Join the club at patreon.com/universetoday. Biggles Tintin, I often tell my young daughters that there are more stars in the universe than grains of sand on the earth. I didn't know where I learned that, but is that correct? That is not correct. There are actually more grains of sand on Earth than there are stars in the universe. So if you go back and you watch the original, I think it's Carl Sagan in Cosmos, he says, you got to be very clear with the words, there are more stars in the universe than there are grains of sand on all of the beaches of the world. And so what he's saying is that it's not about all the sand, it's just the beaches. And that if you do this rough calculation for the number of stars in the universe, the rough calculation for the sand on the beaches of the world, then you kind of get numbers that are somewhat similar to each other. But as soon as you go and you add the Sahara Desert, and as soon as you go and you add the sand that's at the bottom of the oceans, then there's way more sand than there is stars in the universe. So the old calculation was that the Milky Way had between 100 and 400 billion stars, and it's estimated that there are 100 to 400 billion galaxies in the universe. And so if you multiply those two numbers together, but now it looks like there's more galaxies in the universe than we thought before. That actually there's probably more like 2 trillion galaxies in the universe, but they don't have as many stars in them on average. So you still get the same number of stars, you just get more galaxies with less average stars in them. Kojam, can you pick one item from the shelf behind you and tell us why it's there? In the recent patron question show, one of the patrons said, can you give us a tour of what's on the shelf behind you? And I'm like, yeah, I really should. So I'll grab one. Just a random. Okay. So this is from Mount St. Helens. So where I live on Vancouver Island, we are, a few hundred kilometers away from Mount St. Helens. And in the 1980s, the volcano exploded and we could hear it. It was this super loud explosion. It sounded like a bomb going off. 1981. And my stepmother has family in Oregon, really close to where the eruption happened. And you got these incredible pyroclastic flows coming down the side of Mount St. Helens, filling up the rivers, wiping out forests, causing a lot of damage in the area. And then they got this rain of ash that fell on top of everything. And we got a ton of it here, and even in Canada as well, just from the amount of dust that was thrown up into the air. And so my stepmother's family collected a bunch of the ash from Mount St. Helens. And the one thing that they also grabbed, I'll see if I can grab one, they also got some pumice. So these little chunks of rock that are mixed in with the ash, and they float because pumice is less dense than water. And this is a thing that the ancient Romans knew, and they built a lot of their concrete with pumice and ash. So there you go. That is a thing from the shelf. So maybe that's what we'll do once a week, is I'll give you another thing from the shelf. There you go. Ash and pumice from the Mount St. Helens explosion. Yeah, it does float. The chunks of pumice do float. You can actually go down to the beach and find pumice when you are just beachcombing, when you're walking along the beach, looking through for various things that have floated up. Sometimes you'll see little rocks that are mixed in with the seaweed and the little bits of sticks and stuff. And that's pumice from some explosion, some volcanic eruption that happened half a planet away, and the chunks of rock drifted and finally arrived on your beach. Kieran Wild, are there still plans for a Starshade type space telescope? Yes, absolutely. And in fact, we have 2 NIAC 2025 grants are awarded to Starshade technologies. One is a new kind of metamaterial that will make for a starshade that is very stiff, because the problem, the Starshade idea is that you have this, it's made of like mylar, it's made of emergency blanket, right? This really soft material that's very wiggly and jiggly. And so if you move the Starshade to a new position, it's going to ripple and you're not going to be able to make your observations until it settles down. And so the one idea is that you use these metamaterials that provide a level of sort of space toughness, but also stiffness. And so you move the Starshade to a new location and it doesn't jiggle. And you're able to then make your observations right away. And then the second thing is an inflatable star shield. So could you have a star shield that is collapsed down and then you inflate it up, and then it also has this rigid skeleton made of this metamaterial. So the one idea, I've already filmed the interview and it is probably going to go out tomorrow. It's the next interview in the pipeline. If you're watching the NIAC series, that's the one on the metamaterial. And then the inflatable one, I haven't been able to get the interview yet, but it's with John Mather, Nobel Prize winner John Mather, the mind behind the James Webb Space Telescope. And I've interviewed him many times in the past. We're very familiar with each other. And so I'll get him and we'll do that interview. So stay tuned for that. So yeah, absolutely. Starshades are still in the works, still in the planning for the Habitable Worlds Observatory. All right. Thanks for everyone who asked your questions. Now, we record this show live every Monday at 5 p.m. sometime in the world. And the show is 2 hours long. And so if you want to participate in that, there should be a reminder for when the next episode is going to be happening. There should be one that is going to be good for your time zone, no matter where you are on planet Earth. So stick around for that. Now, I'm going to chat about a couple of video games that I am currently obsessed with. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Barry Lake Roofing, David Gilton, David Mounts, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Roebuck, Sean Sargent, Spiderstop.io, Stephen Fowler-Munley, Thomas L. Skadron, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So a couple of video games that I am currently obsessed with. One is a game that I've been playing for a long time and I still just love, which is Slay the Spire. And this is a deck building game where you are playing some character who is attempting to overcome this tower. And as you move through various rooms, you defeat various enemies, you collect cards, and the cards have different synergies working together. And after a while, you can build these really powerful synergies that keep you alive as the combats get harder and harder and harder. And the game is very simple to get into, and yet it is so great. So sort of has so much depth to it. Easy to learn, a lifetime to master. And I've played it for 150 hours according to Steam, and I'm still as entertained by this game as I was when I first started playing. I've beaten it many times, but then each time you beat it, then the game gets more difficult to beat, and so I'm moving my way up that. For those of you who play, I'm at Ascension 8. And then the other game that I'm a little bit late to, and that is Cyberpunk 2077. And that's by the same team that made The Witcher 3 and other Witcher games. And it's so good. Now, I know I had a rough start, and so I waited before I played it. And now, a couple of years later, I'm actually starting to play it. But the world building is so good. The characters are so great. The writing is so good. The gameplay could be better, but it's fine. It's good enough for my needs to be able to experience the story. And it's so great to have just a really well-told science fiction story that is also a video game that you can take actions and do things, and the things you do have consequences. And so if you've been waiting like me for all the bugs to get ironed out and for the price to drop on this game, now's a good time to get into Cyberpunk 2077. All right, we will see you next time.